Hello, happy Halloween. Uh, the next topic I want to talk about is something called a Bayesian network. There are many different Bayesian networks. We'll just look at a simple one. What a Bayesian network is a way to represent probabilities so that uh, automatic programs can derive certain things for us. I'm using as my source a website that is BN Bayesian Network repository. And if you go back from that, you'll find some examples worked out and things like that. And what I did was I took this network here, the Asia network, and I constructed this myself. Now, I hope I got the same results, but who knows? So let's take a look. What this is a medical network. It turns out that Asia, and I didn't know this, is short for autoinflammatory syndrome induced by adjuvants. Where adjuvants are external substances which irritate you, like cat hair or something like that. And DYSP stands for dyspnea, shortness of breath. TUB is for tuberculosis, lung is lung cancer, bronchitis, bronch is bronchitis, and either is kind of a strange setup. It is going to be used to represent two of them happening at once. Now, a Bayesian network is a graph, but it's a special kind of graph. It's a graph called a directed acyclic graph, or DAG, D-A-G. I ought to write that down here. A directed acyclic graph. I wonder if I can get the P and the H on. Yeah. And I couldn't do that. To get down there, I have to go using tabs. Its short name is DAG. And what this means is, if you look, the arrows only go one way. For some reason, I cannot see. There. The arrows only go one way. You can only get from Asia to tuberculosis. You can't go backwards. And the acyclic means that if you start at 1 and keep following the arrows, you can't get back to it. There's no cycles in the graph. This is a pretty standard concept from graph theory. Now, along with this network, you have to have some special information. Asia and smoke have no precedents. They have no parents. So you'll notice that we have a probability distribution for Asia, and we have a probability distribution for smoke. Tuberculosis depends on Asia. So we have to set up a conditional table for tuberculosis based on Asia. Tuberculosis given Asia, tuberculosis given no Asia. The same thing is true for lung and for bronchitis, and either is basically, are both of these true? Lung disease and tuberculosis. Notice if they're both true, you get a 1. If one of them is true, you get a 1. If one of them is true, you get a 1. And if neither of them is true, you get a 0. And probability of X-ray depends on either. And then the probability of dyspnea depends on the ones that it has. It has Bronx and either. And again, there are 4 cases. Bronx and, no Bronx and no, no and no. Now that's the setup that you would be given. You would type that into a program. The site that I am looking at does it in R, and I didn't want to bother figuring out how we're going to do that. But there are certain set of interesting things that we ought to know about probability to help us solve these things. There are 3 in particular. We already know one. We've talked about it. The Bayes formula says that if you want the probability of B given A, where B and A are events, and you know the probability of A given B, and the probability of B, and the probability of A, you can compute the probability of B given A. So, for example, if you were trying to get the probability of dyspnea, probability of bronchitis given dyspnea, you could be able to compute that. Or the probability of an X-ray given either, you could be able to compute that because you have the other direction. So that we have. Now there's also something called the chain rule. And it's pretty easy. It comes more or less from the same argument we use to do the Bayes theorem. It says, if you want the probability of 3 or more things, then you know that that the probability A and B and C is the probability divided by the probability of B and C is the probability of A given B and C. We use that up here. It's the same thing, we've just made it a little more complicated. Now, we also know the probability by the same token, B and C divided by PC equals PBC. So we put these together. If we want the probability of all 3 of them at once, then that equals, from this formula, P of A given B and C times P of B and C. But P of B and C equals P of BC times PC. They line up pretty well. You can see C here, BC here, BNC here, A. It's sort of, you just take it down one step at a time. Now that can be continued. I could have 9, 10 of those if I want to, but I didn't feel like writing them out. I did sort of write those out for the next set. If you have a group of events, a set of events that are distinct events, they don't overlap, and they cover everything. Every case in your entire universe, it fits into one of those categories. Then the law of total probability says that you can compute the probability of any event by getting the probability of that event dependent on each of these times the probability that each of these is likely to happen. So if you have probability of X1, then what's the likelihood that E is going to happen? It's the probability of E given X1 times how many times you have X1. And the same thing, and you keep adding them together. This is called the law of total probability. For example, suppose I wanted the probability of tuberculosis. It's not in this table. However, the probability of tuberculosis given Asia is there, and the probability of tuberculosis given no Asia is there. And I have the probability of Asia, and I have the probability of no Asia because it's just the complement, 1 minus it. So with that information, I could compute the probability of tuberculosis. Now, these kinds of networks I used to derive more information. Believe it or not, this is considered a simple example. It only has 8 nodes. It's not exactly, I don't think most of you are going to say it's simple, but that's what it is. The question is, what could we compute from it? And I think I'll leave that to another video, and perhaps we'll do some of it for homework. So that's what I wanted to say today. I'll see you later, and have a happy rest of the night. Don't forget, we get an extra hour of sleep tonight. We fall back. So see you later. Bye now.